Hello, welcome to this
Hello and welcome to this training program on Compressor. My name is Rahul. Let's begin by having a look at the objectives of this module. At the end of this module, you will be able to 1. Define a compressor. 2. Describe the working principle of compressor. 3. List the types of compressors. 4. Describe centrifugal compressor and its main components. Anjali is a student from mechanical stream. Let's join her for an introductory discussion on compressors.
Hi Rahul.
Hi Anjali. Let's begin the discussion. So, when was the first time you heard the word compressor?
Let me recall. I think the first time I heard the word was when the refrigerator at my home went out of order. The mechanic started checking for malfunctioning of its parts. Finally, he declared that its compressor had stopped working.
Great. I guess many of us might have had similar experiences with refrigerators and air conditioners at our homes. Anjali, do you have an idea of other applications of compressors?
Not much. It would be great if you could give me a detailed insight.
Sure. There is a lot to learn. Let's begin. Compressors are widely used in day-to-day life. Compressors have wide application in industry too. In industrial applications, compressed air is considered as one of the most important utility. The primary objective of employing a compressor is to provide high-pressure air using least possible power consumption. Anjali, based on the previous knowledge, can you frame a standard definition for compressor?
I guess the word itself says everything. Compressor is any device which compresses gas.
Good, but there's more to it. Let me tell you. Basically, a compressor is a mechanical device that increases the pressure of a gas by reducing its volume. An air compressor is a specific type of gas compressor. Air compressor is the device which enhances the air pressure at least 3 times higher than that of atmospheric pressure. Thus, compression ratio for compressor is more than 3. Compression ratio is defined as the high side pressure divided by the low side pressure. This term is used to compare the pumping conditions for compressors.
Okay, that was quite informative. Can you also tell me about the types of compressors?
Sure, you will be learning about it in the upcoming slides. Now that you know what a compressor is, let us move ahead and learn about the types of compressors. Compressors are categorized depending on the action performed on air. Broadly speaking, there are 2 categories of compressors. These include positive displacement compressors and dynamic compressors. Positive displacement compressors are further classified into 2 types. They are reciprocating compressor and rotary compressor. Rotary compressors include lobe compressor, screw compressor, and vane compressor. Similarly, dynamic compressors are of 2 types. They are centrifugal compressor and axial compressor. We will explore each of these compressors in detail ahead. What's the difference between positive displacement compressor and dynamic compressors? The basic difference between the two lies in their method of application of pressure on a fluid. A positive displacement compressor reduces the volume of a fluid physically to increase the pressure, whereas a dynamic compressor changes the velocity of a fluid, which eventually results in the increase in pressure. An easy way to memorize the fact is in the name itself. Positive displacement compressor means a system which compresses the air by the displacement of a mechanical linkage, reducing the volume. The reduction in volume due to a piston in thermodynamics is considered as positive displacement of the piston. Thus, It confines a volume of air or gas within the closed space and increases the pressure by reducing the volume of space. Screw compressor is an example of positive displacement compressor. On the other hand, the term dynamic in dynamic compressor points to the change in velocity of the fluid, which results in pressure rise. The dynamic compressors use rotating elements to accelerate gas or air. The velocity of gas is converted to static pressure rise by diffusive action. When fluid enters the diffuser, the flow velocity is reduced and most of the kinetic energy is converted into pressure energy. Centrifugal compressor is an example of dynamic compressor. Now, let us summarize the difference between the two types of compressors in the form of a table. Positive displacement compressor. 1. Compresses fixed packets of fluid. 2. The velocity of fluid need not to be high. 3. Gives constant flow rate against variable output pressure. Dynamic compressor. 1. Compresses the fluid in continuous manner. 2. The velocity of fluid must be high. 3. Gives variable flow rate against variable output pressure. Previously, we have talked about the types of positive displacement compressors, which are reciprocating and rotary compressors. Now, let's know about reciprocating compressors. In these compressors, air is compressed by the action of a piston in a cylinder with one-way valves and pumped into an air chamber. Depending on the number of compression stages, there are single or multi-stage compressors. A single-stage reciprocating air compressor is an air compressor which carries out compression in a single stroke or stage. The compressor body is similar to the piston-cylinder arrangement. The compression action is carried out by the piston, whose motion is controlled by a crankshaft and connecting rod. In multi-stage compressors, air is cooled in between a stage of compression with the help of an intercooler. Multi-stage compressors feature a series of cylinders, each of a different diameter. Between each compression stage, the air passes through a heat exchanger, where it is cooled. Cooling the air reduces the amount of work necessary to compress it further. So, are multi-stage compressors better than single-stage compressors? Let's find out. Multi-stage compressors have the following advantages over single-stage compressors. 1. Improved efficiency. Two-stage compressors perform less work to compress air to a given pressure, which means your operating costs are lower. Thus, they lower specific power consumption for same pressure differential. 2. Durability. Reduced pressure differential across cylinders, reducing load on the compressor components, thereby increasing life of the machine. 3. Less moisture buildup. Cooler air has a lower moisture content. Moisture in compressed air can lead to equipment failure and premature wear. 4. Few maintenance requirements. Due to smaller components and cooler temperatures, variable components don't wear out as quickly. As a result, recommended service intervals are longer. Depending on the method of cooling, they are classified as air-cooled and water-cooled. The single-cylinder compressors are generally air-cooled, while multi-cylinder compressors are generally water-cooled. Now that we have explored reciprocating compressors in detail, let's proceed and learn about rotary compressors. Rotary compressors use rotors in place of pistons, giving a pulsating free discharge air. These rotors are power-driven. These compressors are not of reciprocating nature, therefore does not have any pistons and crankshaft. Instead, these compressors have screws, vanes, scrolls and other devices which rotate and thus compress air. The rotary compressors have the following advantages over the reciprocating compressors. They require a lower starting torque. They give a continuous pulsation-free discharge air. They generally provide higher output. These are called the workhorses as they provide huge amount of compressed air. They require smaller foundations, vibrate less and have lesser parts, which means less failure rate. They are less noisy. They are much more power effective. Depending on the action of geometry of rotors, rotary compressors are classified into three types. 1. Lobe compressor. 2. Screw compressor. 3. Vane compressor. Lobe compressor. Lobe compressor is also known as Roots blower. It is essentially a low-pressure blower, which is used when high delivery volume but low pressure is needed. It consists of two lobes with one being driven and the other driving. The output is limited to a discharge pressure of 1 bar in a single stage and 2.2 bar in two-stage design. Press menu button to go to the selection menu. Click on Rotary Screw Compressor. Rotary screw compressors use two meshed rotating positive displacement helical screws to force the air into a smaller space. These are usually used for continuous operation in commercial and industrial applications and may be either stationary or portable. Because of simple design and few varying parts, rotary screw air compressors are easy to install, operate and maintain. Commercially, screw compressors are produced in two types, oil-flooded and oil-free. Let us learn about it one by one. Oil-flooded compressors are nothing but oil-cooled compressors where oil seals the internal clearances of the compressor. Though filters are needed to separate the oil from the discharge air, cooling takes place right inside the compressor, and thus the working parts never experience extreme operating temperatures leading to prolonged life. Oil-free screw air compressors use specially designed air ends to compress air, giving true oil-free air. They are water-cooled or air-cooled and provide the same flexibility as oil-flooded rotary compressors. Press menu button to go to the selection menu. To know more. Rotary vane compressors. Rotary vane compressors utilize one of the oldest compressor technologies. They consist of a rotor with a number of blades inserted in radial slots in the rotor. The rotor is mounted offset in a larger housing that is either circular or a more complex shape. As the rotor turns, blades slide in and out of the slots, keeping contact with the outer wall of the housing. Thus, a series of decreasing volumes is created by the rotating blades. They can be either stationary or portable, can be single or multi-stage, and can be driven by electric motors or internal combustion engines. They are well suited to electric motor drive and is significantly quieter in operation than the equivalent piston compressor. Press menu button to go to the selection menu.
Hi, this is Neha. I hope Mr. Rahul has explained clearly about the multiple types of compressors like positive displacement compressor, dynamic compressor, rotary compressor, and its types. In order to know more about compressors, we have to move forward. Let's see in detail about the centrifugal compressor. A centrifugal compressor is a radial flow rotodynamic fluid machine that uses mostly air as the working fluid and utilizes the mechanical energy imparted to the machine from outside to increase the total internal energy of the fluid, mainly in the form of increased static pressure head. Let me clearly make you understand about this topic more. So the compression principle of centrifugal compressor is quite different from that of reciprocating or rotary type compressor. So the centrifugal compressor works like this. When the air passes through the rotating impeller, it experiences force or work which is performed by centrifugal forces. The work input takes place as an increase in pressure and velocity or speed of the airflow through the impeller. The airflow loses its velocity after entering in the diffuser section. The diffuser is actually a fixed or static component that escorts the airflow when it leaves the impeller. This loss in velocity eventually results in an additional increase of pressure. The impeller and the diffuser contributes about 65% and 35% of the total pressure developed or produced in the compressor. Each stage takes up a part of the overall pressure rise of the compressor unit. Depending on the pressure required for the application, a number of stages can be arranged in a series to achieve a higher pressure. This type of multi-stage application is often used in the oil and gas and process industries. Alternately, in wastewater treatment plants, low-pressure, single-stage applications are used to achieve the desired pressure ratio. As we have gone through the compressor and its working principle, let us now see why centrifugal compressor is used. The air after getting compressed will be utilized for multiple processes depending on the usage. Many industries use centrifugal compressor for obtaining certain things like oil-free air, high reliability, lowest cost operation, easy operation, easy maintenance, simple installation, high life expectancy, less foundation, piping and space cost, best specific power consumption and efficiency. It is not possible to use centrifugal compressor for every machinery because each equipment has its own features. In order to avoid it, centrifugal compressors have been designed in two types. The first one, which is single-stage centrifugal compressor, and the second one being the multi-stage centrifugal compressor. Let us start discussing about the single-stage centrifugal compressor. These type of compressors are considered to have an overhung impeller arrangement. Now, let us see about the multi-stage centrifugal compressor. Multi-stage compressors consist of 1 to 10 impellers, and it can be arranged in a variety of flow path configurations. Throughout each and every stage, the temperature and the compression ratio are assumed to be constant. Because the act of compression heats up the gas, there is a limit to how much gas pressure can be raised across any given compressor stage. Higher and higher pressures can be achieved by placing multiple stages of compression in series, that is, having the discharge of one stage of compression feed, the intake of the next stage, and so on. Multi-staging is a term used whenever multiple stages are used to meet the pressure requirements of a given application. Both reciprocating compressors and centrifugal compressors can be configured in multi-stage arrangements. If the temperature from one compression stage is predicted to get excessive, then interstage cooling is required to drop the gas temperature to a safe level before entering the next stage. Problems with interstage cooling systems can result in loss of flow, pressure capability, and in surging. Following are the stages of airflow in multi-stage compressor. The compressor has certain stages in which the air is flown from one to another process. The compressor receives air or other gas to be compressed through an inlet guide vane, and that is where the first stage of compression takes place, and the air or other gas to be compressed will be passed from the compressor to a multi-cooler housing in which the air gets cooled in an intercooler. That is where the second stage of compression takes place. Similarly, the final stage ends when the air is cooled in the intercooler. Last and the third stage of the compression comes to an end when the air or gas in the compressor passes through a plurality of compression stages in the compressor and through a plurality of intercoolers, and finally to an end cooler or aftercooler where the air is left out. This is the summarized points for airflow direction in multi-stage compressor. As discussed in the previous screen, we have already gone through the procedure of air flown in the compressor. In order to make it clearer, let us see the process in the form of a flow chart. Atmospheric air first enters the inlet air filter. It prevents dirt and dust particles from entering the compressor. This minimizes wear and tear and ensures cleaner compressed air to the plant. Intake filters are typically rated between 0.3 and 10 microns, depending upon the size and application specified for a compressor. After inlet filter, clean air enters inlet guide vanes. The purpose of inlet guide vanes is efficient capacity control. It directs the air into the compressor at the correct angle. Now, air enters compressor. In compressor, pressure rise is achieved by adding kinetic energy to a continuous flow of fluid through the rotor or impeller. Between compressor and aftercooler, there is check valve and blow-off valve. Check valve cuts off the reverse flow of air through compressor discharge system at compressor shutdown, and blow-off valve vents some pressure to the atmosphere during unload conditions and shutdown. Compressed air then enters aftercooler. Its function is to cool the air entering to the plant distribution system. A moisture separator normally is installed immediately downstream of the aftercooler. Its function is to remove condensate from an air stream. Now air enters air receiver. An air receiver tank is an integral and important part of any compressed air system. The receiver tank will help remove water from the system by allowing the air a chance to cool. The receiver tank minimizes pulsation in the system caused by cyclic downstream process. After that, air passes through air dryer. Its main function is to remove moisture from the air before supplying compressed air to consumers. The centrifugal compressor is made up of many parts. Let us now see the parts or components individually of a centrifugal compressor. 1. Bull gear and pinion. 2. Gear case. 3. Speed increasing gears. 4. Impellers blades. 5. Labyrinth seals. 6. Bearings. 7. Pressure balancing system. 8. Inlet guide vanes. 9. Diffuser. 10. Intercooler and aftercooler. The term bull gear is used to refer to the larger of two spur gear that are in engagement in any machine. The smaller gear is usually referred to as a pinion. In an integral geared centrifugal compressor, several pinion shafts are mounted around a central drive gear, commonly called the bull gear. The exploded view of a bull gear shows the helical gearing that will mate with the pinion gear located on the pinion shaft. The bull gear is typically driven by an electric motor at 3600 rpm, although various manufacturers may use motors with a rotational speed of 1800 rpm, depending on the compressor application. It should also be noted that in many cases, the bull gear can be driven by a steam turbine. This is a particularly advantageous situation when a large facility has excess steam or the unit can be used as a steam pressure reduction valve, PRV. The gear housing is the casing that surrounds the mechanical components of a gearbox. It provides mechanical support for the moving components, a mechanical protection from the outside world for those internal components, and a fluid-tight container to hold the lubricant that bathes those components. The gear case is split and flanged its horizontal centerline with an oil-tight metal-to-metal joint. The shafts, gears, bearings and bearing oil seals are located in the case. The split casing allows for quick and easy inspection of the working parts. Today, we will be learning about the gear that is used to increase the speed. The speed increasing gears are the high-speed precision. The low-speed shaft with drive gear and two rotor shafts are forged alloy steel. Each pinion is machined integrally with the rotor shaft. The low-speed gear is thermally fitted to the drive shaft. The high quality of these precision gears results in high efficiency and low noise level gear operation. All the gearing is helical type. The rotor assemblies and bull gear are dynamically balanced and overspeed tested. Pinion bearings are tilting pad type. All bearings and each gear mesh are pressure lubricated. An impeller is a rotating component which transfers energy from the motor to the fluid being pumped. The impellers are assembled or mounted on a steel shaft, and this assembly is known as compressor rotor, which will be seen mostly in multi-stage compressors. The rotor provides velocity to the gas with blades that are attached to a rotating disc. These blades can be forward-leaning, radial, or backward-leaning, depending upon the desired output. The impellers impart velocity to the gas with blades that are attached to a rotating disc. The impeller blades are backward-leaning. Backward-leaning blades tend to provide the widest operating range with good efficiency. They are the most commonly used blade shape. Proper sizing of the impeller flow channels is determined by the volumetric flow rate to control gas velocities through the impeller. Most multi-stage compressors are the closed-type impeller design. Impeller construction can be welded conventionally, riveted, brazed, electron beam welded. For most applications, high-strength alloy steel is selected for the impeller material. Stainless steel is often the material of choice for use in corrosive environments. Because the impellers rotate at high speeds, centrifugal stresses are an important design consideration, and high-strength steels are required for the impeller material. Let us now see what are Lebrun seals and what are they actually used for, so the answer is here. Lebrun type seals are used to minimize recirculation losses within the compressor. A Lebrun seal consists of a number of teeth, knife edges, that can be either stationary or rotating. Stationary Lebrun teeth are fitted to the compressor stationary components very close to the compressor rotor. Sealing action is the result of flow resistance caused by repeated throttling across the Lebrun teeth. Lebrun seals are designed so that one of the two adjacent parts, Lebrun teeth and rotor, is relatively soft. The softer material yields on contact without damage to the harder material. Compressor manufacturers select Lebrun seal clearances that are as tight as practical to minimize leakage while avoiding heavy rubbing with the rotor. The next part of centrifugal compressor we are going to discuss is bearing. Radial bearings are used in centrifugal compressor. The radial bearings most often used in centrifugal compressors are the tilting pad type and are continuously lubricated with light turbine oil. The tilting pad bearing design provides rotor dynamic characteristics that help assure smooth and reliable mechanical operation. Radial bearings are sized to be large enough to support the rotor weight, yet small enough to operate at sufficiently low peripheral speeds required to limit operating temperature to acceptable levels. Due to large pressure differences between suction side and discharge side of the impeller, the rotor tends to move towards suction side. This force is a lot more than what bearings can support, so a balanced drum is provided on the rotor. On one side of balancing drum, suction pressure acts. On another side, discharge pressure acts. Net force is balanced by designing appropriate area and geometry on the balancing drum. So in order to sum it up, the pressure rise in each of the stages of a centrifugal compressor creates an axial thrust force that acts towards the inlet end of the compressor. The thrust created by the high-pressure discharge pushing the compressor rotor back towards the suction is cancelled by creating opposing thrust using a balanced drum. Variable inlet guide vane is used to control the mass flow and generate pre-whirl in centrifugal compressors. Variable inlet guide vane can offer power saving up to 9%. Inlet vanes impart a whirling motion to the inlet airflow in the same direction as the impeller operation, reducing the work input. Net power savings at reduced flow or on days colder than the design temperature. Inlet vanes are positioned close to the impeller to achieve maximum benefit. As we have completed about many components, we have an important component to learn about, which is one of the integral part in the compressor, which is known as diffuser. It is one of the key component of the centrifugal compressor. It is provided downstream of the impeller in the flow path. It is the diffuser's responsibility to convert the kinetic energy of the gas into pressure by gradually slowing the gas velocity. Diffusers are designed with different configurations for vane like single row, double row, depending upon pressure and flow capacity. Everything does not work perfectly. There are also few problems that occur in it, like 1. Breaking of diffuser blades due to erosion. 2. Heavy corrosion of diffusers due to moisture carryover. 3. Heavy dust accumulation. Let us now see what is intercooler and aftercooler. The intercooler component is typically designed to eliminate heat that is produced between the different stages of the compressor, whereas the aftercooler is for removing heat after the compression process is finished. When air has been compressed in the first stage, it has an elevated temperature. An example on a 400 horsepower machine with the air inlet temperature at 75 degrees Fahrenheit. The air temperature as it exits the first stage is approximately 242 degrees Fahrenheit. With cooler air being more dense, it is also more easily compressed. Since the air leaving our first stage is at 242 degrees Fahrenheit, we need to cool the air down before we move it to the second stage of compression. In multi-stage compressor, an intercooler is provided between each stage of compression and aftercooler after the final stage of compression to cool the air that enter the plant distribution system. Normally, on compressors as large as centrifugal, the cooling medium will be water. Now that you have completed the module, don't you think that it's necessary for you to check your knowledge by answering these questions? So let's go ahead and take a small test on this module.